Hi, welcome to our next systems of equation video. We're going to talk about finding the equation of a hyperbola. Now, hyperbola is a graph that has the following equation. X times y is equal to some number c, or if you prefer to rearrange it, y is equal to the number c divided by x. Here's what a hyperbola graph looks like. You can see that it's got two parts, two branches to this graph, and both branches never touch each other or never meet. Now, the y-axis is a special line on the hyperbola because the graph gets close to the y-axis in both the positive and negative directions, but the graph never touches this line. Now, this line has a special name called an asymptote. So an asymptote is a line that the graph gets close to, but will never touch. Now, this hyperbola also has a second asymptote, the x-axis. You'll see that in both the positive and the negative x directions, the graph will get close to the asymptote, but will never touch it. Right, this is the center of the hyperbola, and at the moment the center is at the origin, 0, 0. But you will eventually learn how to move the hyperbola around. Also notice that the line y equal to negative x is a mirror line. The hyperbola is symmetrical about this mirror line. Right, well the graph we're looking at right now has the following equation. X times y is equal to 2, so the number c is 2. Now you might prefer to rewrite that as y equal to 2 over x. So how did we get c to be 2? Here's why. Let's look at some points that the graph passes through. If we take the point 1, 2, 1 times 2 is 2. If we take the point 2, 1, 2 times 1 is also 2. If we took the point negative 2, negative 1, two negatives multiply to get a positive, to get positive 2. And the same with negative 1 times negative 2, that also gives us 2. All these values give us a positive 2 value for C. All right, so the example we just looked at, x times y is equal to the number 2, gave us this graph. What if I did a little clever trick and rearranged it or changed the formula to get x times y is equal to negative 2? Well, I'll tell you what happens. The graph appears in the opposite quadrants here. So when we have x times y equal to 2, a positive c, we get our hyperbola 2 branches into these two quadrants. But when we get x times y equal to negative 2, a negative c, we end up with a hyperbola in these two quadrants, opposite quadrants. All right, let's get into some examples. Here's example 1. Determine the equation of the following hyperbola. Right, well here's some points it passes through. We don't need to use 2 points, we only need 1. I'm going to use the point 1, 4. So here's our hyperbola equation, x times y is equal to c. So 1 times 4, I'm using the point 1, 4, 1 for x and 4 for y. 1 times 4 is equal to c, 1 times 4 is 4, so c is equal to the number 4. So my formula, x times y is equal to 4, or you might prefer to rearrange it. The second way is probably a more common way, to be honest. Y is equal to 4 divided by x. So we use the point 1, 4. Quite often to use the point 1, something to figure out the value of c. Right, here's example 2. A hyperbola passes through the point 2, 1.25. What's the equation of this hyperbola? Well, I was just saying that a lot of people like to use the point 1, something, but you can see in this example, 1, something, we don't know what that something is. It looks to be somewhere between 2 and 3, probably 2.5, but I'm not going to guess. So instead of using the point 1, something, we're going to use the point we've been given, 2, 1.25. So the equation x times y is equal to c. So we're going to use the x value of 2 and the y value of 1.25 to go 2 times 1.25 is equal to c. So c is equal to 2.5. So let's write down our equation. X times y is equal to 2.5. You might prefer to write it as y equal to 2.5 over x, or a very clever way is to double the top and double the bottom so we don't get decimals and have 5 divided by 2x. Right, that's us. Thanks.